Hi, my name is Jesus, and I'm gonna explain the 12 topics that we saw in the mass energy one. So first, we have the history of physics. Physics is the research of fundamental concept of matter, energy, and space. For this, the most representative physics are Aristotle, Archimedes, Galileo Galilei, Newton, Maxwell, and Einstein. And it is divided into parts. That is the classic physics that were developed in the 17th and the 19th centuries, and the modern physics that were developed almost in the 12th centuries. For the second topic, we have the measured units. Well, this is the what we use, and also most of the countries use to the measures that are for lengths we use meters, for mass kilograms, for time seconds, the electricity, the amperes, the temperature kelvins, the luminosity, the candela, and the amount of substance, the moles. There are also more measures like the USA's one that for length they use foot, inches, miles, and yards. For mass slugs, for force and weight they use pounds. Also, we have others that are for surface, square meters, volume, cubic meters, speed and velocity meters per second, celerity is meters per second squared, the force is newtons, energy is joules, and power is watts. And there exists more than those that we can use, like tera, giga, mega, kilo, centi, milli, micro, nano, and pico. The third topic talks about the scalar and vector quantities. They exist differences between the distance, the displacement, velocity in forces, and volume in force, but it is in another topic, so I am gonna only explain what it refers in this topic. For this topic, the scalar quantities that are the distance, speed, and volume only talks about a specific quantity. And for these ones that are vector quantities, they talk about the magnitude, the number, and the displacement that they have. For this, we need to take the north, south, east, and west. For the topic 4, it's the operation with vectors. For this, we have two types of methods to know about this. That is the parallelogram method that only works with two vectors. For this, we need a scale and with an origin point. We need to draw a triangle that help us to understand where is the vector. And the tail-toe-tip method that works with two or more vectors, that is with their own scale and help us with the same to know where is the vector, but this is when we need to know more about it. This is the topic 5. It's what I was telling, that it exists difference between the distance, the displacement, the speed, velocity, and acceleration. For the distance is only the length that an object has between something, and the displacement is, it considers the time and the distance that it has recovered. The speed talks about only how much it has traveled, and for velocity it can change between the time and the velocity that it has. And for acceleration is how much it changed in a period of time. the topic 6 that talks about the constant acceleration, but now in vertical form. For this, we use the same as the topic 5, that is the acceleration, speed, distance, displacement, and acceleration. But now we need to consider also the gravity, because as we throw an object in a vertical form, an object has a gravity that is 9.8, and we also need to know what is the initial velocity and the final velocity. Normally for this, the final velocity is it can be any type of velocity, but for the final velocity it's 0, because when it lands it stops the movement. For topic 6 is like the topic 6, but we need to understand for what does it refers to in two-dimensional motion. For this, we are taking the gravity, the acceleration, and the velocities, but also we need to take in consideration the grade of the angle in where it's falling, the object. For this also we need the gravity, the time, the initial velocity to know what is our constant acceleration or our distance. The Newton's law of motion. First, we need to understand what is force. For force is a vector physical quantity that measures the intensity of the interaction between two or more objects. For this exist three laws. The first law, also as the inertial law, states the absence of external forces. A body at the resisting state will also remain this way. The second law is the law of motion, that states the acceleration that the body acquires is directly proportional to the resultant applied force and inversely proportional to its mass. And the third law, also known as the action-reaction law, it states for that every action force there will be a corresponding action. They have their own measure, that for this is we use for force and weight newtons, for mass we use kilograms, and acceleration meters per second square. And the USA use the pounds for force and weight. For mass they use slugs, for acceleration feet per second square. The topic 9 is qualitative and quantitative description of forces. This is a topic that most of the topic talk about the kinetic and static friction, that the static friction is without relative motion and kinetic friction is with relative motion. For this is the formula for the static friction, and that is the formula for kinetic friction. The friction is what can help an object or can stop an object of its movement, of its natural movement that it's having. How can we know about this with a free body diagram that is like this? For this we need to know the degrees of the angle, the weight of the object that is the free body, and the friction that is happening in the other side. The topic 10 talk about the application of Newton's law. In this topic is when we apply all the knowledge that we have been recovering for the last, I think, 3 topics, and we need to apply the friction that is is happening, the weight that is of the object that it has, it can be in a free body diagram or not, and that's why we can apply the gravity or not. Also, we need to take in consideration the time, the acceleration, the speed, and the velocity. Also, displacement and the distance. And the topic 11 talks about the mechanical work and the kinetic energy. For this, this is a topic where we need to learn more about the concepts that we are going to be applying in other topics. The third that is talking about in this topic are the work, that is a scalar quantity that can be applied in a direction of the motion in one object. The energy is anything that can be transformed in work. If I push something, my energy is transforming in work to push that thing. The kinetic energy is the capacity of doing the work in motion, taking the mass and the velocity. This is the formula for the work, and that is the formula for the kinetic energy. And the topic 11 talks about more concepts, that is the potential energy and the principle of the conservation of mechanical energy. For this, we need to learn more concepts, that is the potential energy, that is the capability of doing work given a position of condition. This talk about the angle of how something is moving other thing with the work in certain degrees or certain condition. And the conservative force, that does zero work in round trip. As we all know, the energy cannot be created or destroyed, can only be transformed. So, taking in consideration this, the friction of the sum of the potential and kinetic energy is constant as long as no other energy is added to the system. This tells us that the friction is the only force that can help us in certain times, because there isn't exist another system. Well, that were the 12 topics that we saw in the semester.